I think I'll just wait till 6:32 for a few more people to join. All right, so I'll start now. So today I'll be discussing circular motion, and I'll also be discussing some basic measurements and a bit of forces. Okay, so first of all, I'll review units and how to convert units. So first of all, why are units important? Well, units are important because it helps describe it gives a better description of quantities. So for example, if some person walks from over here to here, then you would say, like, if someone said that the distance is just 3 or something, then you would want to know if it was like 3 meters, kilometers, for example. So it's important to write your units out. So let's say this is 3 meters. And another one could be like, it takes, it could be like, someone could say 3 to get from here to here. They could be talking about 3 seconds, 3 minutes, or 3 hours. Or if this person weighs a certain amount of mass. So if they write just 3, it could be 3 kilograms or grams. So it's always important to write out what the unit is for quantity. So in physics, the standard unit for length would be meters. The standard unit for time would be seconds. And the standard unit for mass would be kilograms. So you can see that in, for example, if we're trying to find the units of acceleration, or actually we'll find velocity first. So we know the velocity equation is equal to the displacement over the time. So the distance is a length. So it would be in meters. And the time's in seconds, so it would be seconds. So the unit for velocity would be meters per second. And for acceleration then, the equation for acceleration would be velocity divided by time. So velocity we just found is meters per second, and we know that time is in seconds. So you would write it as meters per second over second, which is meters per second squared. And some people might write meters per second or -2 to get rid of the division sign. Meters per second. And also another one could be force. So force is equal to mass times acceleration. So we know mass is in kg, kg times acceleration, which is meters per second squared. So the unit for force would be kg times meters per second squared, but people just write it as newtons. And it's also important to, it's important to know that for example, if you're given a question that says the velocity is equal to 30 miles per hour, you should always try to convert it to its standard units. So you would want to convert it to meters per second. And that's what I'll talk about next, which is how to convert units. So if we're given this equation again, v is equal to 30 meters per, 30 miles per hour. So we write 30 miles per hour. How would you convert it to meters per second? So first of all, how many, you would write like this. So to cancel out the miles, you would have to put the miles in the denominator. So this would be 1 mile. And how many meters are in a mile? It would be 1,609 meters. And how many, and to cancel the hours, we would put the 1 hour in the numerator instead. So how many seconds are in an hour? Well, there's 60 minutes an hour, so 60 minutes, and then times 60 seconds would be 3,600 seconds. So now you're able to cancel this out with this and this out with this. So you're left with it being 30 times 1,609 meters divided by 1 times 1 over 3, and just 3,600 seconds. So you're left with meters divided by seconds, and then 30 times 1,609 divided by 3,600. So that's the best way to convert units as well. So in this diagram right here, you can see that some other base units could be like electric current, and which is amperes, which is A, and also it gives like the SI prefixes. So yeah, that's that diagram. So this is a question about converting units, and I'll give you like 2 minutes to do it, and you can write the answer in chat if you get the answer. And if you guys have any questions, just message me. Okay, so I think I'll go over the first question now. So it says that the speed is in meters per second. Okay, find the speed in meters per second equivalent to 55 miles per hour. So this is just like the example I just gave you. So if you're given like this, how would you change this to meters per second? So again, try to get the miles out of the numerator by putting this one in the denominator. So again, there's 1,609 meters in 1 mile. So this canceled out already. And you put the hour in the numerator. So there's 3,600 seconds in an hour. So again, cancel this out. So you'd get 55 times 1,609 divided by 3,600 and then meters per second. And then you would get that as 25 meters per second. You guys understand that one? Okay, so now I'll go to the second question, which is what is the volume in cubic centimeters for a tank that holds 16 gallons of gasoline? So if it's 16 gallons, you would just need to cancel out the gallons. So for 1 gallon in the denominator. So how many cubic centimeters are in a gallon? It would be 231. Oh, hold on. This is okay. So they first put it inches cubed, and then you would get rid of the inches cubed by putting it in the denominator of this. Oh, hold on. Okay, so you would first put it inches cubed, and then you would get centimeters cubed by doing this. But I think it would work the same if you would just put this in centimeters cubed to begin with. So you would get that to be 16. So this cancels out. So it'd be 2.231 and then times 2.54. Oh, this is inches. So this would cancel with this, and then you would square this. I'll cube this. So 2.54 cubed centimeters. Okay, hold on, I wrote that kind of bad. So it would be 16, and then the gallons cancel out. So that's 231. And then the inches cubed cancel with this. So this is 2.43, 54 to the power of cubed, centimeters cubed over 1 inch cubed. So that would cancel with this. So you're just left with 16 times 231 times 2.54 cubed in centimeters cubed. And then that would be equal to 6.1 times 10 to the power of 4 centimeters cubed. So that's how you convert units. And now I'll talk about dimensional analysis. So the dimensional analysis is basically just checking the units for a problem to make sure that you got the right answer. So for example, if you try to find acceleration and you somehow got the equation like velocity over distance, then that would make sense because it would be meters per second over meters, which would not be equal to meters per second squared, which is the correct unit for acceleration. So you would know that this is probably, this is definitely wrong then. So you can use dimensional analysis to check that. And to check dimensional analysis, you would write it like this. So length would be equal to meter. So for acceleration, the units would be meters per second squared. So the dimensions per unit would be in length. The dimension for seconds would be in time, t. And the dimension for kilograms, which is mass, would be in capital M for mass. So the brackets just mean the dimensions of it. So if you're gonna write it this way for meters per second squared, it would be L over T squared. And you can also write that as, right over here as L T negative 2. So that's the dimension for A. So this is important because you're also able to check, for example, the equations for something. For example, so later on today, we'll be learning about centripetal acceleration in a uniform circular motion. So the centripetal acceleration is proportional to the velocity and the radius of a circle. So you would put it to H and V. So these are just random constants you can find. So acceleration, centripetal acceleration is equal to meters per second squared. So as we found above, it would be L T negative 2. So L times T power negative 2. And for velocity, we know that's equal to meters per second. So that's L over time. So that would equal to L over times t negative 1. So that's equal to L times t negative 1 out of A, and then times R, which is just L because R is in meters. So L to the power of B. So now that we know that, we can expand. So we can basically get rid of the brackets because they don't really mean anything. So L times t negative 2, which is acceleration, is equal to, and basically it's like use exponent rules to put this in each equation. So it's L to the power of A, and then times t negative A, and then times L to the power of B. So if you guys know exponents already, you know that if it's the same base, you can cite L times power of A plus B. So we L times t power negative 2 is equal to L A plus B, and then times t to the power negative A. So then you can just compare these two equations and see that this is power of 1, so this, and negative 2 has to equal negative A. So if you know that negative A equals negative 2, then cancel out the negatives, and you know that A equals 2. And so since you know A is equal to 2, this equation would be 1 is equal to A plus B. So 1 is equal to A plus B. And plug in 2, so 1 is equal to 2 plus B, and B is equal to negative 1. So if you plug that back to the equation up here, which is A centripetal acceleration is proportional to V times power of A and times R to power of B, you get AC is equal to V to power of A, which is 2. So A times 2, power 2, and then times R to the power of B, which is negative 1. So you get that V squared over R negative 1, just 1 over R, so this V squared over R. So we use dimensional analysis to check that AC is equal to V squared over R, which is actually the equation for centripetal acceleration. Okay, so now I'll give you a similar question to do about dimensional analysis. So this question says that an important milestone in evolution of the universe, just after the Big Bang, is the Planck time TP, which is just the Planck time. And this value depends on the 3 fundamental constants: the speed of light, that's 3.00 times 10 to the power of 8 meters per second. The gravitational constant, G, which is 6.67 times 10 to the power negative 11 meters cubed over S squared times kg. And Planck's constant, H, is equal to 6.63 times 10 to the power negative 34. Hold on. I forgot to write the unit. This one's unit is kg over meters squared times seconds. Oh, this is wrong. Times meters squared over second. So it asks you to use dimensional analysis to find Planck's time. So I'll just tell you now that the Planck's time, since it's depends on the 3 fundamental constants, is proportional to C, let's say to the power of A, times G to the power of B, times H to the power of C. By the way, these A, B, and C can be any different numbers, like it could be I, J, K, or Z, X, Y, Z, or anything like that. So just like the last problem, I'll just start you off with the question. So you would use the units for each of them and then plug them into here and then find time. So I'll show you that. So the T is equal to seconds, so it would just be time. That's dimensions of T. is proportional to C, which I told you before is meters per second. So that would be L, which is meters, and then times, it's equal to meters times seconds per negative one. So that seconds is just time, so it'd be T negative one. And then times G, which is A. And then G, which is meters cubed divided by seconds squared times kg. So L cubed, this would be seconds per negative two, meters cubed, second negative two, and then kg negative one. So second would be T negative two times kg divided by negative one. So that would be times mass now at negative one to the power of B, and then times H. So that's kg times meters squared over seconds. Again, we're going to move that to seconds, so we second negative one instead of this. So then, and then finally times kg, which is mass, times meters squared, L squared, times second power negative one. So it would be S negative one. And then power C. So like I did on the previous question, you would just need to expand the constants to each variable, add the variables, and then relate it to this t here to get it so that only the t's, this is should be t, only the t's here end up in the equation. So I'll give you guys like a couple minutes to do that as well. And just message me in the chat if you have any questions. Okay, so I'll go over it now. So if I just do what I did before, the t power of 1 is equal to L A times t to the power negative a, and then times L power 3b times t power of negative 2b times m to the power negative b, and then also times mc times L 2c, and then t power negative c. So since we know that the t, I'll just write out here, is equal to, so we have 1, 2, 3 L terms. So again, multiplying just means adding the, so L plus L times power of A plus 3B plus 2C. And then we also have two T terms. So T, negative A, negative 2B, negative C, negative A minus 2B minus C. And then times, we have two mass terms. So it'll be negative B plus C. So if we're only trying to get one T, then we would want these two to be equal to 0 and this one to be equal, and then this part of the T to be equal to 1. So we can write that as A plus 3B plus 2C is equal to 0, negative B plus C is equal to 0, and then negative A minus 2B minus C is equal to 1. So in this equation right here, if we move C to the other side, it would be negative B is equal to negative C. So B is equal to C. So we can then plug this into the equation of this. So A plus, let's plug B, C into this B. So it'd be 3C now, plus 2C equals 0. So A is equal to negative 5C. So if you add these, it would be equal to 5C, and then move it to the other side, it'd be negative 5C. So now you can plug these two equations in this one to make this equation all C's. So it'll be negative 1 times negative 5C, which is 5C minus 2B, so it'll be minus 2C minus C is equal to 1. So this will just be equal to 2C is equal to 1, and C is equal to 1/2. Therefore, if you plug this C back into these two equations, you can find now that, I'll write them again. So A is equal to negative 5C, B is equal to C, and C is equal to 1/2. I get that right? A is equal to negative 5. Okay, so plug 1/2 into each of these. So this is equal to negative 5/2, and this would also be equal to 1/2. So now that we have these two constants, we can plug them back into the first equation right here. So it would be the Planck's constant is equal to C to the power of A times G to the power of B, and also H to the power of C. So we have our constants, and now we just plug in. So C to the power of A, C to the power of negative 5/2, times G to the power of 1/2, and then H to the power of 1/2 as well. So I'll just expand this. So this equation would be 1 over root C to the power of 5. This would be root G, and this would be root H. So if you put that all in here in one equation, it would be square root of G times H over C to the power of 5. So since we have our constants right here, you would just plug each into the equation, and I'll get the solution right now. So it would be square root of G, which is 6.67 times 10 to the power negative 11, times H, which is 6.63 times 10 to the power negative 34, and then times 3 times 10 to the power of 8 divided by 5. And I think if you also check the dimensions for this, it's also the same. So you would get, the dimensions would turn out to be seconds. 1.35 times 10 to the power negative 4 to 5 seconds. So that's Planck's time, and that's a lot smaller than the 1 second that we have. So now I'll talk about, oh, by the way, do you guys understand this question?
Not really.
Oh, well, what do you guys not understand about it? You guys can write in chat if you guys what you guys don't understand about it, and I can answer them. But right now I'll just move on. So for the order of magnitude question, so order of magnitude is used to approximate something. For example, if it's a large calculation, or if it might be a large calculation, then it's easier to just use order of magnitude. So for example, if there's like a lake or something, then to find how much water is inside the lake, you might just use like the cylinder equation, like the volume of the cylinder, because they have about the same shape, even though the lake probably isn't 100% circular like a regular cylinder. We can just assume it is since we're just estimating, and also like we can just assume the height is the same all around, even though it might be like shallower in some areas and deeper in some areas. So we can just assume like maybe this is 10 kilometers or something. So that's a small thing to know. So now I'll actually start talking about uniform circular motion. So uniform circular motion is the motion an object undergoes when it's moving along a circle at a constant speed. So if we have okay, let's say a ball of mass m, and it's moving around a circular path, then it's going at a, let's say, constant velocity. So the velocity when it's going around the circular motion will always be tangent to the circle. And there's also going to be, let's say this is the radius r. There's also going to be a centripetal acceleration and acceleration for the ball that's going towards the center. And if you have a string or something, then there's also going to be a centripetal force, which is pulling it. But I don't think you guys have learned forces yet, so I won't talk about that right now. Okay, so again, that's what I was talking about before. If you see in this diagram, the velocity is always constant and moving along the circle at a tangent. Okay, so now I'll write the formulas out for circular motion. So in this diagram, you don't have to worry about that right now. So let's say in a circle, and an object's moving like this. So it's like a bigger circle. So this is the radius and this is the radius. And this is the change in the angle, and this is the arc length. I'm going to assume you guys know what that is. So it's just a distance to travel around this curve. And this is the change in angle that it goes. So starting from this point and going to this point. So let's see. So this is the arc length. So the change in angle is going to be the arc length over the radius. So you can see that if this arc length is the entire circle, it's just gonna be circumference. So it'd be 2 pi r. So let's just assume that's, it starts from here and then goes all the way around. Then the arc length, the change in arc length would be 2 pi r, and then it would just be r still. So it would be equal to 2 pi, which makes sense because the entire circle is equal to 360 degrees, which in radians is equal to 2 pi. And that's another thing that's important. So to convert to radians, so if it's theta, to convert it to radians, you would just find it in degrees, what it is in degrees, and then times 2 pi divided by 360. So for example, if this is like a 90-degree angle, it would be 90 degrees times 2 pi over 360. So that would be 4. So 2 pi over 4 is just equal to pi over 2. And if you guys know some trigonometry, you know that this is correct then. And you can just do the same if you know radians and you're trying to find the degrees. You would just do the radians times 360 over 2 pi is equal to the degrees. Okay, so with that knowledge, you can find that. So first I'll talk about finding the angular speed. So the angular speed is the speed it goes around the circle, and this is not the same as velocity. So the angular speed would be equal to, in angular terms, it would be equal to the the delta theta over delta time. So delta theta, which we found here, is equal to delta s over delta r. This is equal to the arc length over delta r divided by delta t. So if we write that out, it would be delta s over delta r is equal to 1 over delta t. And you would notice that this is the distance over the time, which is just the velocity. So we can write this be 1 over r is equal to the velocity, so just times v. So v over r. So omega is equal to delta theta over delta t, and it's also equal to v over r. So if you multiply r to the left, you would get v is equal to r times omega. And this is an important equation to know, and as well as this one. So another important thing is period, t, and frequency f. So frequency f. So the period is basically how long it takes for it to so for example, for an object to go from here to here, that would be like how long it would take to do a full rotation. And the frequency is how many rotations it would do, how often it would do it. So it would be the period is equal to 1 over the frequency, and frequency is equal to 1 over the period. So if we're using the equation for the angular speed, delta theta over delta t, and to make it full circle, it would be the theta would be 2 pi, like we thought before, and the delta t, which is the time it takes to go on the full circle, would be the period, which I just told you before. So this is another important equation. So the angular speed is equal to 2 pi over t. So this just means how long it took to go full circle. And we can write the same equation using velocity. So we know that velocity is equal to omega over r, and omega is equal to velocity over r. So if we write v divided by r is equal to 2 pi t, and multiply r to the other side, you get velocity is equal to 2 pi r over t. Okay, so now um, I'll tell you what this diagram up here is. So in this circle right here, you have this velocity vector going like this at this point, and this velocity vector going like this at this point. And if you connect these two, these both have radius r and r, and this would be delta theta, and this would be this is a change in like how much distance it went. So this is v1, v2. So you can combine these two vectors to create this triangle over here, which I'm pretty sure I taught last time. So this would be v1, v2, and this would also be the same delta theta as this one, and then this is going to be the change in v. So if you guys know some basic geometry, then these two would be similar triangles. So you can write that this delta v over this delta s, or I'll try length, it would be delta L times this v over this r. So these two velocities would be the same because, like I said before, in uniform circular motion, the velocity is always going to be equal in magnitude, but just in different directions. So it'll be equals v over r. So if we cross multiply that, it would be delta v times r is equal to v times delta L. And delta v, if you divide this, delta v is equal to the velocity times delta L over r. So, and like I said before about the centripetal acceleration, we already found that the equation is v squared r, but this is another way to prove it. So we know that acceleration is equal to the velocity divided by time. So if you plug that into this, it would be change of velocity between time. So it would be v times delta L over r divided by delta t. And you can write that as v delta L over r times 1 over delta t. And you might notice again that this right here, delta L over delta t, is just velocity. So it would be v over r times v is equal to v squared over r. You guys really don't need to know how to prove this way, but it's important to know that the centripetal acceleration is equal to v squared over r. And then also, it also points towards the center of the circle. So the velocity is tangent and the centripetal acceleration is pointing toward the center. And later when we discuss forces, the centripetal force is also pointing towards the center. Okay, so I'll now introduce forces so that that makes more sense. So forces are like a push or pull. So for example, if we have a crate right here and this person over here pushes it this way, then they're doing a force on the box. And the force is a vector quantity because it has magnitude and directions. So the most important equation you guys should know right now is that the force is equal to mass times acceleration, and the net force is equal to the mass times acceleration as well. So the net force is just all the forces acting on like an object. So for example, if there's friction on the floor now, and there's a box here that's being moved this way as well, being pushed this way, then the net force would just be the pushing force, and then plus the frictional force, which is basically friction just tries to stop the way it's trying to go. So if it's trying to go this way, then the friction force would just act back on it. So it'd be F. So it'd be F frictional. So that's just a basic introduction to forces. So there's also different kinds of forces. for example, there's the if a box is here static, there's the gravitational force, and there's also a net force, not net force, the normal force. And there's also, like I said before, a frictional force. And there can also be, for example, let's say there can be tension force as well. So if there's like a rope here and someone's pulling on it, then there's a tension force. There's a lot of different forces, but I won't get into it right now. So in circular motion, there's also forces. Like I said before, if you have this time you have a string connected to a ball and it's moving in a circular path, the string's right here, circular path. So this is radius r. And when it's moving along this path, there'll be a tension force. So the centripetal force, which is acting this way, just like the centripetal acceleration, is equal to ma c. So the centripetal force would be mv squared over r, which is just the centripetal acceleration times the mass. So I'll give you this first question. So this has to do with the centripetal force. So like I said again, if there's like a ball, a 150 g ball at the end of the string is revolving uniformly in a horizontal circle. So it's going like this with the radius equal to 0.6 meters. The ball makes 2 revolutions in a second. What is its centripetal acceleration? So the 2 would just be equal to the period. So, and then you're trying to find the centripetal acceleration, which is AC is equal to v squared r. So in this problem, you're just trying to find the v. So I'll give you a couple minutes to do this question and ask questions in chat if you have questions. Oh, sorry. Actually, I said this wrong. The period is not 2. The frequency is 2 because it's saying that the ball makes 2 revolutions in a second, which is how many times it can go around a circle in 2 seconds, which is what the frequency is. So as you know, the frequency is equal to 1 over the period. So the period is equal to 1 over f. So the period is to be equal to 1/2 or 0.5 seconds. So now you guys can solve it. Okay, so I'll just go over the answer now. So like I said before, we're trying to find the centrifugal acceleration, which is equal to v squared over r. Oh, another thing I want to say is that since we know that the velocity is equal to the angular speed times r, we can plug this into here. So it'd be AC is equal to omega squared r squared over r. Cancel this r out, and it would be the angular speed squared times r instead. So those are the two different ways you can find it. But in this case, since you know the period is equal to 0.5 seconds, and the velocity is equal to 2 pi r over t. So you know r and you know t, so it's 2 pi times 0.6 meters divided by period, which is 0.5 seconds. And pi is dimensionless, so it would just be equal to 7.54 meters per second squared. Oh, no, not second squared, just meters per second. So now that we know that, we can plug it into the centrifugal acceleration. So AC is equal to v squared over r, 7.54 meters per second squared over r, 0.6 meters. So that gives you 94.8 meters per second squared. Okay, so we're almost out of time, so I'll just give you guys one problem to do and one more problem to do, and I'll explain it afterwards. So I'll give you like 2 minutes. So this is like the same question as the one we just did, but with different numbers. Okay, so I'll just take you guys the answer now. So we know that the centrifugal acceleration is equal to v squared over r, and that it completes 2 full rotations every second. So this is also the frequency. So the period is equal to 0.5 or one half seconds. So again, we can just do 2 pi r over t, or we could have also done 2 pi r times f, because 2 pi r times 1 over t frequency is also equal to 1 over t. So just plug into that, it would be 2 pi rf. So we can just do it that way instead. So r we know is 1.5, and then the f is just 2. So that would be equal to 6 pi. We can just write it in pi for now. So 6 pi is the velocity. So the centrifugal acceleration is 36 pi squared over 1.5. And the answer to that is 237 meters per second squared. Okay, so that's all for today. Hope you guys have a good weekend, and I'll see you later.